We're going to look more at the university application that we started looking at last time. One thing to keep in mind is there's parts of this that we're either not going to go over or going to gloss over that I think are a little advanced at this point. So we're not going to cover every page or anything, but we are going to cover the key concepts, especially related to those things like when tables relate with each other. That we will cover, and we'll look through examples of how to retrieve stuff and so on. Here's one of the pages in the application. Refresh it. Let me get to it. This is the instructor's list, and it is the same as all the lists that we've seen so far, except when you click select, it shows a list of courses for the selected instructor. So there's an additional button here, or not button, but link here that when you click on it, it expands and shows all the courses that instructor is teaching. And if you select the course, you see the students enrolled in that course. So I thought this would be a good one to go over because this has more advanced link commands than we have gone over so far. We've alluded to link without going over it a whole lot. Let's take a minute to back up and talk about what link was. There was some resources back a while ago, a link tutorial that talks about link, and link is language integrated queries. Yes, language integrated queries. It's very powerful because in the past, when you wrote SQL statements, that would be the other way to access data. When you wrote SQL statements, they weren't compiled per se. In other words, they were just all in one string, which means that if you spelled the word select wrong, or if you got a table name wrong, or a column name wrong, or something like that, your SQL command would just be in a giant string, and therefore it would not be compiled to make sure that it was a valid SQL statement. However, when you went to run the statement, you would get a runtime error and it would blow up because you had the wrong word for select or table name or column name. Now keep in mind that, in some cases it was obvious, it would blow up right away. But in some cases, errors like this would be very conditional. Like if the user picks a certain mix of criteria, maybe they get this error. And runtime errors are not good. It's much better to get compile errors. So what we do is we are going to write our queries within the language of C# using methods that are available that can be compiled and verified for accuracy. Let's click on some of these and see which ones look interesting. This looks a little bit interesting. Why should we learn link? Link is a unified querying language that can work on a collection of objects in memory, an ADO data set, SQL Server database, entity framework, XML documents, or any other data source or collections. So if you had a giant array, you could write link to query that and pull out the things that you need. And this is more details about that. I guess that's all that's interesting to me on this level for this page. The fact that with this language, we can query any number of different data sources. In fact, you'll see a lot of examples where they're not querying something from a database, but they're querying like a list of or a collection of objects or something. There's two basic syntaxes to writing link. One of them is a query method and one is a syntax method. The query method resembles SQL statements. And here you see an example. This looks sort of like a SQL statement. There's a from clause, there's a where clause, and there's a select. Just like there was in SQL, although arranged a little bit different. The method syntax is more like this, where we have our data source and we use dot notation to pull different items from the collection. So here's an example where we have a list and we want to get a list of everything that is greater than 5. So we say from this integer list, from the objects in an integer list where the object is greater than 5, select object. So when we run this, we will get everything greater than 5. So we'll get 6, 7, 8, 9, 10. That same query, integer list where X object greater than 5. In other words, where the object is greater than 5. So we want the objects where the object is greater than 5, and we want to convert that to a list. I don't care which way you write them. In examples, I probably will favor the syntax version, the method syntax rather, as that syntax just makes more sense to me. The idea with this is we're writing using functions that feed into other functions. This integer list is a list. That gets pumped through the where function, which filters out only those objects that are greater than 5. And that gets pumped into the toList function, which takes that collection and produces a list from it. Like operators. This is rather extensive. This is just sort of an overview of what they're talking about. We have the select operator. That's what we want to pull from the list. And in the method syntax, that would be done this way. It's just selecting a field. Take the time to read through some of these and get familiar with LINQ, especially if you see something in one of the examples that you don't understand. We're going to be going over one of the examples today from the university one, and that is the one that I demonstrated. The ability to select someone, see their courses they taught, select a course, and see that. So let's go look at the index for instructors. Drag this up to, it'd be nice if I could drag it into the other screen. Because it sort of gets in the way sometimes. Anyhow, looking at pages. We have instructors, and we're going to look at the index. We're going to start by looking at the code behind. Code behind is kind of an old term. I just got used to calling the file with the C# code the code behind. The model, I think, is the more appropriate model term. Okay, this has three attributes. An instructor index data class. We'll take a look at that class in a minute. What this is this is a class that contains instructor data and things related to the instructor. Because as you see, we have courses related to the instructor, and we have indirectly, we have students related to an instructor. Right? Then we have an instructor ID and a course ID. Let's talk about the mechanics of how this page gets called and what gets put on the query string in both cases, in all cases rather. When we run this, when the page loads initially, nothing on the query string. Look up here, all it says is localhost/instructors. So when there's nothing on the query string, it produces simply a list of instructors. Based on what is on the query string, the page knows what mode it's in and what it needs to display. So nothing on the query string means only instructors. If we click select here, we call the page back, and there is a /5 on the query string, which indicates a course ID. We click this and we get, I'm sorry, yeah, that, let me back up for 1 second. That's not a course ID. When we click on the select, that is the instructor ID. When we select a course here, then we get put on the query string the course ID. 5 actually is not on the query string, it's part of the URL. And we'll show how that works in a second. So there's 3 modes of this page. Absolutely nothing after instructors. Instructor ID as part of the URL. The course ID as included in the query string. So let's see how that works within our code behind or our model. We have code in the model. That looks first of all to see if there's an ID. If there's an ID, it knows that it wants additional information about the instructor. So it pulls the instructor's courses. So this is if the instructor ID is not null. It's going to pull the value from a specific instructor. We'll look at these link statements in a minute here, but I just want conceptually for you to understand what's going on. First step, we're going to pull all the instructors. Second step, because we need all the instructors to do the list. All right. Second thing, if there's an ID on there, then we know to pull the courses for the given instructor, the selected instructor. Finally, if there's a course ID, we need to do a query to pull the students for those. Let's look at how the URL is constructed. Route ID equals @item ID. This is the same way that we pass data to the edit, details, and delete page, is by including as part of the link the routing ID. So that gets tacked onto the end of the URL and therefore can get pulled back in to the URL. So the first time it's loaded, it contains select, and then we go from there. So let's look at the statements in this get async. There is a class on this page called Instructor Index Data. And that is not the one that I thought it was. It is someplace else. Here we go. Instructor Index Data. This relates to all the data that is needed on the Instructor Index page. What does it consist of? On that page, we might need, well, we're definitely going to need a list of instructors. We might need a list of courses, and we might need a list of enrollments. Now, you wouldn't have to create a separate class for this, but they did. You could have these as simply lists or enumerables in the index model itself. But this just makes it a little tidier. Instead of having three enumerables here, we have the one instructor index data list. So, first thing we do when we load the page, we create a new one of these objects. We're going to populate, first of all, the instructors in this class. So we have an instance of instructor index data. The first thing we're going to do is we're going to populate this. What are we going to populate it with? We're going to populate it with instructors, but other data as well. So we have, confusing myself here. That one, this one, this one. Okay. Instructors are, we're going to pull from the context instructors, that is pulling effectively from our database context, which gets passed in through dependency injection and is a school context. So it's effectively the school database, but we're pulling related data too. We're pulling, along with the instructor data, we're including the office assignment. We're including the courses, and then we're including the department. When we say department, the word then means that this one goes with this include, not with instructors. So let's look at the list. Let's look at this instructor object, because that's what we're really getting, is a list of instructor objects. The instructor object contains all the fields that are relevant to the instructor, but it has a couple of collections. All right. It has an office assignment collection, and it has a course, or has an office assignment, and it has a course collection, because there's only one office assignment. Office assignment is pretty straightforward. It gets populated. It has the same key, the instructor ID, and therefore it pulls a location and populates this office assignment object as part of the instructor object. An instructor is only going to have one of those. So this is an example of the one-to-one relationship, I believe. Each instructor, though, has a potential for a list of courses. Now, why doesn't it do this automatically? we have to explicitly say, when we retrieve the instructors, that we want to include the office assignment and we want to include the courses. Why do we have to do that? We have to do that because there might be some times where we want a list of instructors and we don't need all the courses that they're teaching. All right, let's say we had a page that was a campus directory. It just had a list of all the instructors and their phone extensions. All right. If we had a page like that, you wouldn't really need to have all their courses, because all you're going to be displaying is information about the instructor. And pulling up all the courses for every instructor is more of a resource drain. You have to go to the database and retrieve it. The objects are going to be bigger, going to take up more memory, and so on. Now, again, this could be substantial in a large organization. Like in this example, we have a half dozen instructors and we have like, I don't know, half dozen courses. No big deal. But at a large college with hundreds of instructors and probably thousands of courses, that could constitute an awful lot of resources taken up to retrieve all those courses. So yes, we have to say that when we retrieve these instructors, we want to populate their office assignment object and we want to populate their courses collection. So what that will do is it will create this object that's populated with all the instructor stuff along with a list of courses and the office assignment for that person. I didn't want to do that. So now what do we have? We have this in our instructor data object. One of these. It has a list called instructors. What we have just done is we have populated that list of instructors with the list that we pulled through the database, right? And we're also populating for each instructor the office assignment and the list of courses. So this guy here contains a list of all the instructors, and populated is the office assignment, and also populated is a list of courses. And by the way, we want it ordered by their last name. Probably would be good to put a second order by there. If you wanted to order it by last name and then first name or whatever. And then we want to take that and create a list from it. The initial time when we load the page, this will be all that we'll do because the ID will be null and the course ID will be null. Then we're going to display the page. So now for each item in the instructor data object, the instructor data objects list of instructions for each item in that, we're going to pull out ignore this one. We can pull out the last name, first name, hire date. If there is an office assignment, we can pull out the location. And then we can, right in the list, show a list of courses. at least a concise list of courses. And I didn't point that out before. We'll take a look at that in a second. And finally, we create the right page. Should be, oh, there's select. I was gonna say I didn't see select. My mistake. And we have that select that's going to call this page back and include as part of the ID the page itself. There's a page variable called ID, which is the last part of the URL. All right. The rest of this doesn't apply because this is the first time we're loading the page and we have not populated the instructor data's course list or the enrollment list. We do have a for each to display at least the course title for every course that the instructor teaches. Yeah, I guess there is there. A list of them. So this is data that comes from that instructor index data object that we created, for which we have populated the office location, which some have and some don't, and the list of courses. Because remember, when we pulled that instructor, we didn't have to, but we did say that we wanted to include the office location and the list of courses. Each instructor object in that list in the instructor index data contains those things filled in. So now we click select. And now there is an ID that gets passed. And now we display the courses taught by the selected instructor. We display really full information about it. Here we just display the number and the title. Here we display the department. And if we needed to, we could display other pieces of information as well. Let's see how that happens. Click on that link. We do everything we did before. If there was an ID, that is, if the ID was not null, we set the instructor ID equal to that ID value. It's over here. We find in our instructor data that specific instructor. Notice we're not going to the database again. We're pulling that from the instructor data object that we created. We're finding that ID in the list of instructors that are part of that instructor index data object. And we have already retrieved all the courses for that instructor, so we simply say, fill up the instructor data with the courses. So we don't have to go to the database to pull the courses because we already pulled them up here. We've pulled for every instructor the list of courses. We're simply saying, as part of the instructor index data, what we want to display these courses. Then we have code in here that loops through for each item, as long as that course field isn't null, it's going to loop through for each item, and it is going to display the course ID, title, and department name. Now, it will make sure that the one that's selected is still selected. So when we select it the first time, it will be selected once we retrieve the page, once we redisplay the page. Last step of the way. They click on select, displays the list of that. They click on select again. Now there is something on the query string called course ID, and we go out to the database and retrieve the students in the selected course. Okay. Now, how do we accomplish that? Well, we're going to still do those first two things. So that remains the same. But this time, since the course ID is not null, we're going to grab from the instructor data, list of courses, the course that we've selected. Remember that instructor index data has a list of instructors, a list of courses, a list of enrollments. At this point, the list of courses is populated with the courses for the selected instructor. We're grabbing now the specific one that was selected. How do we know that? Based on the ID. That's part of the query string. From that, we're going to grab a list of all the enrollment objects. We're going to grab a collection for that course. We're going to grab a collection of all the enrollments. What are enrollments? An enrollment is this row, which matches a course and a student. Associated with each of these enrollment rows is a student ID and a course ID, and a student object and a course object. Where were we? So now we have all the enrollments. And for each of those enrollments, we are going to retrieve the student associated. And we're going to set those enrollments, set the enrollments on the instructor data equal to this list of enrollment and student data that we came up before. We use that then to loop through. and display the students and the name. I know this is a lot to absorb. It honestly, the first time I saw that, the first few times I saw this, I had to go through it and stare at it for a while before things started becoming clear. In a nutshell, what we are doing is we're creating one of these objects that's going to contain the data that could possibly appear on the page. It includes a list of instructors, a list of courses, and a list of enrollments. So this is a list of all instructors. This is a list of all the courses for the selected instructor. This is a list of all the enrollments for the selected courses. Now, they probably could rewrite some of this because it looks like they did things in sort of an inconsistent way in retrieving enrollments. I don't know if there's really a good reason for that or not. All right. Let's take a look at the create instructor. This is something, I'm not going to go over their example. I'm going to talk about how I would have done it instead. Or actually, let's look at edit. When we go to edit an instructor, we go in and we have a list of all the courses, and you select the ones that you want them to teach. So let's say I want Abercrombie to teach calculus, composition, and literature. They're a very smart, versatile person. So I click save. I have 2 professors for calculus, which is okay. And they teach the 3 people, the 3 courses rather. Now, if we look at this, could you imagine what a page would look like for Learning Community College, where there are literally probably hundreds or thousands of courses offered each semester? That'd be an awful lot of checkboxes. I would not take this strategy in creating courses, course assignments for instructors. What would I do instead, and what do I suggest if you have a case of this where there's a many-to-many relationship between 2 things? In this case, there's a many-to-many relationship between instructor and course. Instructors have a list of courses. Courses have a list of instructors. What I would do, if I were doing this, is I'd do something like this. Because what we have is we have a many-to-many relationship between instructor and course. Remember, many-to-many relationship can exist in a relational database, but it can exist within our model. All right? So what got put in our database when we updated our database? Let's take a look and see. Oh, here we go. Oh. school context. Let's look at the tables that got created from our model. It created a course instructor table. There is no course instructor model, but there's a course instructor table because Entity Framework Core knows that you can't have a many-to-many relationship between these two. And yet that's what our model had. Our course had a list of instructors. Our instructors had a list of courses. So it solved that many-to-many by creating an intersecting entity between course and instructor called instructor course or course instructor or whatever it was. And this is where it goes if we do a query on instructor and pull up all their courses. Now, what I would suggest doing is I would suggest doing like what they did with the enrollment data. Looking at this application, I mean, it does a lot of good things, but there's a few things that cause me to scratch my head. And one of them is they did this with enrollments, but they didn't do it with course assignments. Because enrollment contains a course ID, a student ID. This is the intersecting entity between course and student. So we have course, student, and they created a model for enrollments, which is the intersecting entity. Why they didn't do that in this case, I don't know. It seems inconsistent for me. So what I would have done is I would have created a course assignment table, kind of like the office assignment table. I don't know why they did that one either, to be honest. Actually, is there? Yeah, there is a separate table with a one-to-one relationship. I have a feeling they did some things in this example just to show how, like, any possibility of things would work, how you could do things multiple ways and all that, because it's not really necessarily done consistently. What I would have done is I would have created a model for the instructor course table. I'd probably call it course assignments. And I'd model it after the enrollment, where I would have a course ID and an instructor ID in that table, and a course instructor ID, which would be the primary key. So what I would have in my model would be, get rid of all this extra stuff. I would create a model for this that's going to do the same thing database-wise, and then I could scaffold this table, the intersecting table, and I would use that. And then I could write the interface any way I wanted to. I could have, for instructor, I could pull up the course assignments, or for the course, I could pull up the course assignments. Either way. That would be a much better way to do that than the way that they do with the interface. I had a student in their project a short time ago that wanted to do something that was using this as their model, and they just had headache after headache. So I finally said, you know what, don't follow their example, do it this way instead, and it worked out a lot better for them. All right, that's all I had for today. Are there any questions at this point? What we'll probably do is we'll probably go over some more examples of these, the examples that I think are worth emulating. And if you have any questions at all or questions about your project or whatever, please feel free to ask. If not, I will see you next week.